In this video, let's talk about how to splice a strand list, one linked list, into another linked list, right? And we'll think about this recursively. So when you think about recursion, you tend to like to think about your base cases first. So let's imagine a base case here where we're trying to insert or splice strand in at index 0, right? So we can imagine this might happen if we were to call the splice function with, say, arguments of head and index 0 and strand. What do we want to have happen here? Well, what we're saying is we want to essentially prepend the strand onto head, right? How might we do that? Well, let's think about what our references are going to look like after this operation occurs. Rather than this z, the last node of the strand referring to null, we want it to instead refer to the head of the original list, right? So we're going to need to update that reference. And it turns out once we've done that, we're effectively done, but what we need to remember is that the new head of this strand is going to be, the new head of this linked list is going to be the strand rather than our previous head, right? Because y is going to be the first thing we want to have happen in this list. So we need to do two things in this case. We need to say that the last node of strand, its next property is going to be the head of the original list. One thing I want to point out that you can hopefully make use of is this last function is one that you've already written before. So you know how to get the last node of the strand using the last function you've already written. And so you should make reuse of that here. So once we've updated the last node of strands next to be the head of the original list, what are we going to do? Well, we're going to then also return the strand. Return the strand. And what this has the effect of saying is the point of splice as a function is to say, all right, if you call me and give me a head of one linked list, some index you want me to insert another linked list, which is a strand at, I will return to you the head of the linked list, which has that operation completed. The head of the new linked list is going to be just strand, which is the start of the strand we prepended into this linked list. All right, so that's how we would think about the base case where the index was 0. There's another base case that we must consider. Let's talk about the case where the index is 1 instead. So let me get rid of these notes here. And let's talk about base case number 2. So what do we want to have happen when index is 1? Well, this is another interesting case. When index is 1, what we're saying is we want the head to still be A, but we want the next element to be the strand, right? Because we think of this as index 0 and this is index 1, and what we're saying is we want strand to start at index 1. And then anything that came after index 1 in the original list will be appended to the end of strand. So effectively, what we would like our references to look like after this base case has completed would be something like this, right? The first node of head, which was at index 0, is no longer going to refer to the next node it previously did. It's going to refer to the head of the strand. The last node in the strand is no longer going to refer to null. It's going to refer to the very next node that the strand is being inserted at. And so what this will leave us with is a list where A is going to refer next to Y, is going to refer next to Z, is going to refer next to B. We've spliced this sublist in at index 1, right? So that's the goal that we're trying to accomplish here. So let's think about how we might actually make this work. We need to get these references updated for this to work. So what we're going to say is we want to make this connection here happen. So what we can do is we can say heads next is going to be the strand, right? And strand is going to refer to the head node of the strand, right? And so heads next will be assigned strand, and so that's going to create this reference here. We need to be careful though, because that's going to lose our reference to the next node. So we don't want to do that step before we set the last node of the strand's reference to be the next node in the list. So let's actually do that first. I'm going to select this here and move it down so that there's room here. And this order does matter, right? So let me just move this down real quick. So let's talk about why this order matters. If we erased this reference first, we would no longer know what comes after the head. So what we need to say is that the first thing that we need to do is say the last node of strand, its next is head.next. And so what that's saying is take this reference here and assign it to the next property of the very last node of our strand, right? And so we've got that connection made. Then what we're going to say, so that was the first step in this base case. The second step is heads next is now strand. So we're going to drop this reference here and set up this reference. What's the last thing we need to do? Well, we need to return head. And that will give head back to the color, and our job will be done, right? We've said the head's next node is now the first part of the strand. The strand is connected together. The strand's last node is now connected to what was previously the next node, and our job is done. Once again, how do you find the last node of the strand? Well, you should use the function you've already built for that. So these are our two base cases. How do we think about the recursive case here? So the recursive case here is going to look a lot like the recursive case of remove. If you did not do remove recursively, this may be a little bit tricky to think through, but let's talk through it real quick. So let's imagine that instead of saying splice head 1, we're going to add a third node to this original list. All right, so our third node is going to be, say, C. And C is going to be the new head node. And, sorry, I can't write right now. This is the new head node. And so what we're going to say is, what if we wanted to actually splice in at index 2 instead? So notice we had two base cases based on the index. 0 was the index where we're going to prepend. 1 is the index where we're going to inject right after the node. And now 2 is our first recursive case and our only recursive case. And so at 2, that's saying, all right, 0, 1, 2, we expect splice to be inserted here so that our indices after the splice is completed will be 2, 3, and then 4, right? So the updated array links that we're hoping, or sorry, the updated reference links are, instead of this node pointing to B, it will point to Y. Z will not point to null anymore. The end of the strand will now point to whatever came after the index we were trying to insert at. Well, how do we make this work? Well, it turns out we've already made that work when we're dealing only with these nodes, right, in the previous base case. So our recursive case is actually going to be pretty simple. Right? We're going to look to see, hey, is this number greater than 1? And if so, and of course, if heads next is not null, then what we'll do is we will recursively call splice on head.next, right, which is the rest of the list. And we're going to take this index, which we would have just called index, right, and subtract 1 from it. And we're going to keep the same strand. Like, the strand is not changing as we're moving through this recursively. The list that we'll be moving through recursively is the original list. Right? And so notice that this head.next is going to refer to this part of the list directly. This index minus 1 is saying, all right, subtract 1 from 2. So index minus 1, when this recursive step happens, is going to be just 1. And strand will continue to be the same thing. What I want to impress upon you is that when this is the case, this is exactly like the base case we've already handled. And that base case is going to return to us a reference to the new head of the list with this strand spliced in. So what we can do is we can rely on that fact, right? So if this call to splice recursively is giving us back the new head, and we can assume that once it's been injected at the right place, that head value is going to be correct. Well, we can just say at this point on the outer call, the recursive step, we want to say head.next is whatever this gives us back, right? And so this is the trick to doing this recursively. We would say head.next is assigned the result of calling splice. On the next element, we're going to subtract the index we're looking for by 1, and we're going to insert the strand. You'll have to spend some time to think through why this works, but the intuition is what the guarantee Splice is making at our base cases is that when we get to a point where our index is 0 or 1, as long as we have a head node and a strand, what we're saying is we're going to give you back the new head node of that list with the strand correctly inserted, either prepended or appended, based on those two base cases we covered at the beginning of this video. And so because that's going to give you back the new head, we can recursively build up and assume that whenever we say head.next is assigned the result of calling splice recursively in this way, we know that eventually the strand will be spliced in at the correct place. And even if we start with an n that's greater than 2 with a longer list, this should still just work out because the result of this recursive case is that we'll also return head again. I would encourage you to spend some time thinking through the two base cases of Splice using recursion, as well as the recursive case and why this comes together as it does.